We're going to take the next few minutes to look at several images that have various bit depths and color modes and why that matters when editing files in Photoshop. So the bit depth specifies how much information is available for each pixel in an image. The more bits of information per pixel, the more values are possible, and the more accurate tonal representation can be achieved. The most common bit depths in Photoshop are 8 and 16-bit. A file's color mode determines the number of channels that the file contains, as well as how the color information is stored within that channel. We're going to take a look at 3 of the most popular color modes: grayscale, index color, and RGB, and how they interact with bit depth. In this first example, we have an 8-bit image in the grayscale color mode. It's limited to one channel, which can represent 256 different values. Now, in most instances, 256 shades of gray represents a large enough number of values to display what appears to be a continuous tone black and white, or more accurately, a grayscale photograph. This second example is an 8-bit image in the index color mode. It's similar to the grayscale mode in that it's limited to a single channel. However, the values in the index color are colors, not shades of gray. So a single channel helps keep the file size down, which is ideal for creating like ad banners or similar images to post online. But in most instances, index color mode is unable to display a large enough spectrum of colors to show what would appear to be a continuous tone color photograph. To try to appear continuous tone, the 256 colors can be customized. They can be chosen based on the colors in the image or mapped to specific color palettes. To help simulate more than 256 colors, this color mode can use different types of dithering or alternating between 2 or more colors to help fool the viewer into thinking that they're seeing a continuous tone image. The drawback of using index color, as we can see in the enlarged preview, is that it's prone to banding in subtle areas of gradation, and it doesn't hold up well when enlarged or when significant editing needs to be done to the photograph. This third example is an 8-bit RGB file. The key difference is that instead of having only one single channel like the grayscale and index color modes, the RGB color mode has 3 channels, a red, green, and a blue channel. With 256 possible values in each channel, when these channels are combined, these images can display over 16 million possible colors, which in most instances can represent a continuous tone photograph. Notice that in the enlarged area, we no longer see any banding or dithering in there. However, 8-bit images still can't reproduce all of the tonal values or colors in the world. So to help solve this problem, we can work in 16-bit. So while a one-channel 16-bit per pixel grayscale image can display 256 different shades, a one-channel 16-bit per pixel grayscale image can contain over 65,000 shades of gray. And while a 3-channel 8-bit per pixel can display over 16 million colors, a 3-channel 16-bit per pixel RGB image can display literally trillions of colors. However, 16-bit actually exceeds both our ability as humans to perceive color, as well as the number of colors that can be reproduced, and it increases file size. So why do we want to work with 16-bit images? Because 16-bit images have the potential for maintaining a higher quality image and withstanding greater manipulations when we're editing our photos in Photoshop. If we look at this original image and we look at the histogram, and basically a histogram maps the values in an image from black on the left to white on the right. And we'll be discussing histograms more in depth in later videos. But for now, notice that the histogram is nice and smooth. There are no gaps in it. If I'm working with an 8-bit file and I need to make a big change to it, for example, I need to lighten up the image significantly, Then we'll get these gaps in the histogram. And these gaps represent areas in the image where there are no longer color values. And if the gaps get too large, then the quality of the image will decrease and we'll most likely see banding or distinct breaks between different colors in different areas of the image. If I'm working with 16-bit images, however, I have far more latitude when making those same edits, and we don't see the gaps in the histogram. I should also mention, although it's beyond the scope of this essential training course, that Photoshop also supports 32-bit images, which are primarily used in the film and gaming industry when rendering 3D objects and creating computer-generated imagery for special effects. All right, let's take a look at bit depth and color modes in Photoshop. When we create a new document over on the right-hand side, we can choose our color mode and we can also change our bit depth. For now, I'll select 16-bit and then choose Create. And when we open that file in Photoshop, we can see that it's an RGB image and that it is 16-bit in the title bar. Okay, let's move to Bridge. And this time I'm going to open this thistle.jpg file. We can see in the title bar that this is also an RGB image, but it is only in 8-bit, and that's because the JPEG file format only supports 8-bit, not 16-bit. Okay, let's return to Bridge again, and I'm going to select this cactus.dng file. So this is a raw file, but I want to point out over in the metadata area, we can see that the bit depth is actually 14-bit. So more often than not, raw files are either 12 or 14-bit, but when we open these through Camera Raw into Photoshop, we'll only have the option of choosing 8 or 16-bit. Let's go ahead and double-click on that. It'll open it in Camera Raw, and sure enough, if we click on the Workflow option hyperlink down here at the bottom, we can choose whether or not we want to open this as an 8-bit or a 16-bit image. I'll open it as 16-bit so that we keep track of all of that good information. I'll choose Open, and we can see in the title bar it's an RGB image in 16-bit. If you're using Lightroom Classic or Lightroom, they are set by default to open the raw files into Photoshop as 16-bit as well. Now, if we need to change the color mode or the bit depth in Photoshop, we can use the Image menu and then select Mode. We can see this file's in 16-bit. I'll go ahead and choose 8-bit. Now, when we convert from a higher bit depth to a lower bit depth, Photoshop will need to discard information. And this is a lossy conversion that can't be fixed by going into the other direction. So if I simply went to Image and then Mode and converted it to 16-bit, none of that information would come back. At this point, we could always undo that change, but if I were to save this file and close it, I would have thrown away all of that information. All right, returning to the Image menu and then Mode. Now that my image is in 8-bit, we can see that I can change this either to index color or to grayscale. I'll choose index color, and I'll use the local palette, which means it's going to select colors from the image and convert this to index color. But if we zoom in, I think you can see the banding in the image. The subtle gradations of color in the sky just don't hold up well. Right now, we could undo this edit, but if we save this file as an index color image, all of that extra information would be lost. So for the most part, choosing the correct bit depth comes down to file size versus flexibility and quality when editing. An 8-bit image will be smaller than 16-bit. However, 16 and 32-bit images contain more information and can produce higher quality results when large edits are made to an image. I prefer to work in 16-bit whenever possible. A larger file seems like a fair trade for more color and tonal information when making edits to my images. If you're using the exercise files for this course, you'll notice that a lot of them are in 8-bit, but that's just to try to keep the file size down.